Excellent. Well, I think given the fact that we've got only an hour to talk through what is a fascinating and complex topic, I'd like to get a start on this. Welcome to Buro Happold and to our webinar on whether it is ever okay to demolish a building in the 21st century. The role, we're talking, particularly this is the second in a series of conversations we've had, we're talking about the role of technology in understanding options and making decisions about the future of existing and new buildings. I'm Sarah Prichard. I am the UK Managing Director for Buro Happold, an engineering consultancy in the built environment, really focusing on both the creation of new and the redevelopment of existing buildings in a sustainable way that makes equitable lives for people, places, and the planet around us. I lead a team of about 600 technical staff whose, this is the real focus of what we're trying to do. I'm also personally passionate about doing my part as a business leader and a leader in the built environment in terms of sustainability and net zero, the path to net zero. I'm a member of the ACE, the Association of Consultancy and Engineering Board, and I chair their climate change advisory group. So this is something that's particularly close to both parts of my professional life. So welcome. The theme today will be around the role of technology in understanding options and making decisions about the future of existing and new buildings. We're going to explore how technology is enabling net zero best practice, the role of optioneering, the contribution made by the Internet of Things and collaborative design software. We're also going to explore if the technology currently available is fit for purpose now and going forward, and where technology vendors working in the built environment could focus next to ensure that the built environment minimizes the negative impact on the environment. I'd like at this point, before we start the questions, to introduce the four panelists that we have with us today. Marta Bouchard is an AEC sustainability strategist at Autodesk. She leads the sustainability strategy for architecture, engineering, and construction within their sustainability and foundation team. Within the role, Marta seeks to position and extend Autodesk's technology to transform the AEC industry to realize more sustainable outcomes. Simon Bird, welcome Simon, is a director at LOM. With his passion for strategy and innovation, Simon creates high quality and effective design solutions for clients across a range of sectors. As a director of LOM, he takes a leading role on strategic interior and architectural projects, as well as leading sustainability and well-being agendas in the practice. I'd like to welcome my colleague May Winfield, who's our Global Director of Commercial, Legal and Risk at Buro Happold. She's a senior construction and insurance lawyer with over 16 years experience. She's a leading expert in building information modeling, BIM, and related technologies. May was one of the first UK lawyers to start investigating the legal and contractual implications of BIM, beginning her specialism back in 2011. And last but not least, Jules Barker is the Global Director of Product WiredScore at WiredScore. He's responsible for the creation, delivery, and evolution of all products and associated services, including the WiredScore digital connectivity certification and Smart Score. So welcome to all of our panelists today. Welcome to all of you who are now on the call. A couple of minor things that we should just remember. I'm sure that you're all on mute at the current time. Please remain on mute. If we can bring you in towards the end, we certainly will. We are using the chat function today. Please put chat and Q&A questions in those boxes, and my colleagues will be helping to moderate those, and we can come to those questions towards the end. We're also fortunate enough to have a digital scribe on the call today, and Josh will be creating, as you can see, he'll be creating a visual record of the conversations that we have here today. We'll bring that up to look at in more detail as we go into the wrap-up session. Okay, so I hope that's okay for everyone who's on the call. I hope that's all very, very clear. I think it would be a good time now to start asking some questions of our panelists. I'm going to go to each of them in turn to ask a question, and then we'll hear from the others, because we need to get a good conversation going around these points. Marta, I'm going to come to you first. I hope that's okay. Sure. So can I ask the question is, how does technology enable us as industry experts to take a strategic lead on the decarbonisation of both existing and new buildings? Over to you. Thank you.
Thanks. I love this question, and thanks for kicking it off with such an important baseline. So maybe just for the sake of level setting the conversation, I just want to unpack that a little bit. I'll break down technology and decarbonization and what we mean by that, just so we can sort of define the opportunity here. So I guess it's a bit of a cheeky question, but could you imagine if we didn't have technology? Like, what would that look like for our industry? We'd be using drafting boards and slide rules, or I don't even know. But, you know, technology is here to stay. And there's this digital transformation all around us, automation and manufacturing and self-driving cars and phones and building management systems. And, you know, this tech is all around us, and it's getting faster and more predictive and more collaborative, you know, virtual reality to start to plan and visualize. So I feel it's, in our industry in particular, you know, we use so much technology to design and to build, and that essentially supplements our expertise that we bring to the built environment. So let's unpack decarbonization. You know, I think we're all here today because we're mindful of that. It's a priority if we want to mitigate climate change, that we need to think about how to influence and decrease our greenhouse gas emissions. We know that almost 40% of the global greenhouse gas emissions are attributable to our industry, you know, construction, renovation, building operations. So we want to decarbonize this big slice of our Earth's carbon pie. Then, you know, what are we going to do with our buildings? When I break that down a little bit, I just want to set the stage for the opportunity here. You know, there's always a need to put human needs and health and comfort first. But for the point of this conversation, I sort of want to leave like occupant and occupant behavior out of the conversation and focus on more like the physical building assets that we can influence in terms of decarbonization. So we're talking today about existing buildings, the retrofit and renovation of them, the continuing operation of them, and also a little bit about new buildings, because both of these sort of contribute to this entire space. So with our existing assets, you know, we can start to think about decarbonization, just the concepts at large, right? I'll get to the technology in a second. You know, higher thermal performance, more energy efficient systems, energy management systems of those operations. And then when we need to renovate, thinking about circularity and what's really necessary, and recycling and reusing and procuring smart materials around sort of environmental impact. And then with our new buildings, we have a bit more of a, you know, sort of fresh slate to start with, but there's huge opportunities for energy and material efficiency. On the energy side, you know, designing for efficiency in every way, optimizing massing and orientation and climate and solar and renewable potential, high performance envelopes, passive energy systems and ventilation systems. And then after all that, you know, right sizing super efficient active systems. On the materials side, right sizing our buildings to begin with, right? Let's not oversize, let's not over design. And then along the way, like thinking about that greenhouse gas impact, our carbon footprint of every one of those design decisions, and practicing circularity. So all that is to say that, you know, the decarbonization process, it's totally dependent on that industry knowledge on how we're going to tackle these different issues in the existing and new building space. And I think, you know, something I really believe passionately is that there's, you know, the key to decarbonization is that we have to understand there's no silver bullet. If there was a quick fix, we would have figured it out by now, right? And so putting decarbonization into practice is essentially a massive systems thinking exercise. You know, recognizing the interrelated effects of all these different systems, whether it's renovation or a new building, you know, there's design and build criteria that have integrated trade-offs. It's a system of trade-offs. And so it could be energy, cost, carbon. For example, you know, what might save a ton of heating energy, super insulated building might have a carbon trade-off because of the insulation materials if they have a high embodied carbon footprint. The list of these sorts of things can go on. So I think where technology and decarbonization and our industry expertise comes together is the fact that we as experts on this call and attendees today, we don't need to become technologists. In fact, quite the contrary, I really think those experts need to leverage our industry expertise and professional practice and then use technology to our advantage, to take that strategic lead. We use technology a lot of different ways, but at the basic level, to draft faster, to document, get building permits, to design in 3D, building information modeling, to simulate performance and anticipate risk, to predict future scenarios or future performance around energy and cost, and to capture existing conditions, to get the reality perspective of what we got, and to analyze existing integrity, is it still fit for purpose. All of this is to say that I think technology can actually inform those decisions. That's really at the root of all this. I think, frankly, technology can be used to do a lot of the heavy lifting that otherwise would take a person like me or you a lot of time to figure out. So, the opportunity to decarbonize, I think, comes with leveraging technology to run the computations, analyze the simulations, anticipate the risk, optimize our solutions, have this collaborative environment where we can calculate the trade-offs, and along the way, quantify the metrics, quantify the energy, the carbon, the time, the cost. So I think technology is our friend right now, right? It's rapidly changing, but I really see it as an opportunity that our industry can use for a business advantage, but especially as a climate and decarbonization advantage. I hope that sets us all up for a really exciting conversation today.
Marta, it does indeed. I was like, yeah, totally agree. Well, that's my perspective. I agree with lots of what you say. It really is a massive enabler. And can you imagine where we'd be without it? Simon, can I come to you with your thoughts on how technology enables us to drive forward in this? And then I'll move to May.
Yeah, sure. I mean, I think coming from Marta's point, I think technology is helping us, and it is very sophisticated and getting more so. I think when we get involvement with full design teams and we have the models up and running, excuse me, when we have the models up and running, it's quite sophisticated. We can measure all those things. And I think that works really well, both in existing buildings and repurposing, retrofitting buildings as well. New buildings is more straightforward. I think where there's a little bit of a gap, just to talk about where there's gaps in the technology at the minute, which I think we can backfill from those lessons, is in the early stage design decisions. So how can we really help? Because I think it's that involvement at early stages with clients when there's a choice of building new or retrofitting or extending or staying where they are and rethinking. And I think if we can get that technology to work backwards to enable us in early decision making, then we've got something that will be very effective and very powerful. Structural engineers do a lot of this ahead of the rest of the profession. I think there's a lot of data there with the superstructure and all the elements that go within it. I think the challenge for us in talking from an architectural perspective is there's so much more stuff that needs to be measured, and there's so many more things that can go in, as well as retaining and reusing existing elements, parts of buildings or existing things within buildings. And I think over time, if we can build those databases and those lessons learned from the projects we're doing, learning the technology, feeding that back into the early feasibility, optioneering stages of projects, will really be where we'll be able to demonstrate a lot of benefits to clients and help us in conversations with clients to say, look, there's different ways of doing this. Here is your trade-off. There is a trade-off between embodied carbon and operational carbon. It is better for you to stay where you are, retain the superstructure, and let's refit it. We can help in that process. And I think hopefully over time, that sophistication will feed back to the early stages, because I think for us, that's the big missing element at the moment, architecturally, in those early discussions.
Super, Simon, that is a really good point, and that real challenge about what we know and how we can get in early. May, can I come to you for your thoughts, please?
Yeah, I think one of the benefits of technology in this space is the ability to analyze and understand vast quantities of data. So you have your existing building and you go back 20 years and say, well, should I keep it? I don't know if it's going to be more sustainable to tear it down or retain it. And things like for example, in Buro Happold, we have various types of toolkits, digital twin, life cycle assessment, going in and say, what's a carbon use? If we change the use in this way, if we change the building slightly, what's the impact, and then run those figures through the computer, and the computer spits out the particular decision. Also, I think with technology, you also have different types of materials. So with your existing building, you can use the new materials, the new types of dealing with structure to make it more sustainable in a way that we possibly couldn't have done before.
Thank you, well said. Jules, can I finally come to you with your perspective from WordScore on how we can use technology to get us a strategic lead?
Yeah, sure. Thank you. And thanks for inviting me. Marta commented that tech is here to stay and tech is our friend. And I strongly agree with that. I think there's this, there's a seductive and wrong kind of Luddite fantasy that if we could just smash all the data centers, everything would be all right. And while we need to acknowledge that all this technology we put in buildings has an energy cost, not just running the technology, but processing the data that comes out. And it has an environmental cost in terms of environmental degradation of digging the material up. But the benefits just enormously outweigh the costs. And the question you asked at the beginning was how do we as the industry experts, the people on this call, take a strategic lead? And I think it's really important that we evangelize about the importance of technology being a fundamental building block to any solution. You know, you can build a sustainable building without technology. My shed is a good example of a sustainable building without technology, but that's not going to function as a 21st century office, for example. You need the technology for it to work. And as Simon said, I think it's our job to help the industry understand that and understand what the trade-offs are, understand what the different decisions are, because I think there's three critical ways that you need technology to achieve decarbonisation, to achieve positive environmental outcomes. The first one is the understanding. You need the technology to really understand what's going on in a building, and I think we'll probably come back to that a few times in this call with things like digital twins and BIM modelling. And that supports good decision making. That understanding of what's in a building, what could be in a building, supports good decision making, as well as the ability to then model forward. If I choose this piece of technology, if I choose that, this will be the cost in terms of environmental cost and financial cost. The second one is to provide, once the building's up and running, to provide real-time information about what's going on in the building. That you absolutely need technology. You need the sensors, you need the backhaul, the connectivity to the data centers, etc., to do that. And that in turn allows you to make better decisions day to day about what's going on. And then the third thing is you need the technology to actually really optimize on that, because once you've put the technology in the building, there are millions upon millions of different data points relating to that building, and no human can possibly be on top of all of those things. You see a sort of, historically, I think we've tended to try and manage buildings by having one person with a wheelie chair moving up and down a desk from different screens, trying to understand what's going on. And that's just impossible. You need intelligent buildings to be able to optimize themselves. And without all of that, we won't be able to decarbonize, certainly the operations of the building.
My apologies. Thank you, Jules. That is absolutely super. I think there is, you say, there's a real trade-off, but huge amounts to learn and think about in this space. I'm now going to ask our second question around retrofitting of buildings. And I'm going to go to Simon first, if that's okay, and then come to the other panelists. If our focus is on retrofitting existing buildings rather than just building new ones, what technologies exist to simplify the design and the use of low carbon materials? What more do you think that vendors could do to ensure the built environment minimizes its impact on climate change in this context?
Yeah, this is definitely an area that's growing at the moment, and it's an area that's getting increasingly more sophisticated. Where we've had challenges on projects where we've had to hit a SCAR accreditation, a LEED accreditation, BREEAM accreditation, it's always been in sourcing the data from the suppliers and getting those certificates and accreditations in where we've had the biggest challenge, getting that together. And I know this is changing at the moment. that is our biggest challenge. And also, again, as I was saying before, I think if we can learn some of our lessons from how these things are measured, we can bring those back in to aid our decision making. At the moment, it's hard. I think Marta was saying technology has the it has the potential to do a lot of this work for us, but at the moment it's hard to avoid doing the hard yards and really putting the effort in. I think especially with retrofitting, that's absolutely true. So there's some principles we've got where we can look at what materials we're using, what we're retaining in buildings, and which projects we should use. But we haven't found a kind of single source of technology at the moment that sort of informs us in those early design decision-making sessions. It's something that comes through and develops over time in those projects. And retrofitting is a particular challenge. We're doing a few at the moment. We're dealing with existing buildings from all sorts of different eras where we're having to do a bit of forensic detective work to work out what was there in the first place. And this is, I don't know how technology will address this. Maybe Marta's got something up her sleeve, but it's a real challenge going in there. Like, it's one thing having the 3D surveys, knowing what we're doing, great, and that helps us work ahead on projects and really start to sort out our details at a very early stage. But choice of materials in retrofitting is a massive challenge, especially where we're going for retain, reuse, recycle. And that's not just for the whole building. That principle is applied to elements within it. So it's a challenge. I look forward to technology being able to come in and help us out a little more there, to be honest.
It's, you know, listening to you talk, it's almost, you know, I was a structural engineer in the past, and it's almost back to those rules of thumb that we can use at these early stages. And potentially, whilst we wait, you know, we need to use technology at an appropriate time rather than, you know, always piling it at the start. And it's so simple.
Yeah, and I think just something just to mention quickly from what Jules said before as well is, I think even when we're retrofitting, we still should be, for reasons of maintain and reducing carbon in the future, these buildings should be designed to be as flexible as possible. And this is where that technology that's put into the space, allowing us to monitor and change those spaces. A building we design is never the same on day one as it is on day 3, as it is on day 450. And it's that change over time which technology allows us to monitor and allows us to put flexible designs in place that allow that building to have a continued life.
Well, an excellent addendum to that. Thank you, Simon. Marta, I'm going to come to you. Maybe you do have the silver bullet
up my sleeve.
And then over to Jules. Okay.
Well, there's not going to be no surprises on this screen to shock you all. But you know, I think Simon makes such a real point that everyone in the industry can relate to. I mean, I've definitely been in the trenches, you know, taking field measurements to then document it in CAD or in BIM, and then to eventually get to the designing after you've documented all that. You know, there is not a single source of technology that's going to do that entire sort of start to finish process. Right now, it's a relatively disjointed space around the existing buildings, renovation space, primarily for the same reason Simon touched on, is we don't really have a lot of digital documentation of what's standing. It's rare that you get, you know, digital files from that existing building. If you're lucky, you get some old pieces of paper and then you need to digitize it essentially. And then again, start your process. There's a whole workflow involved in just capturing existing information, which I think is an enormous opportunity for technology to solve. You know, there are plenty of pieces of that workflow, you know, the reality capture, the like scan to BIM, the different ways that we can take photography and photogrammetry into sort of and GPS data essentially to create these 3D simulations in a digital environment. But that is a huge opportunity for technology to continue to improve and to link to our otherwise more familiar toolkits like BIM, where when we start from scratch and we're sort of, you know, you have your X, Y, Z sort of 0 point where you can begin. It's, you know, we've got to sort of overlay existing content. And that is then complemented by or supplemented by in the field, real life data collection. I'm thinking core drills of wall sections. What's in there? You know, what's going on inside? And then having to layer that information into our building information models. So we are definitely working in the technology space to stitch all that together because we know that painful workflow. And it's something that I think as we lean into decarbonization and we recognize the value of our existing building stock, I think this is a huge opportunity for our collective industry to put that knowledge and build the technology behind it to make that so much better and faster. There's a lot of opportunity there to decarbonize through making that workflow work.
Thanks, Marta. As you're telling us, we're on a journey here, and there's a way to go. I think one of the most important things is as we use digital technologies nowadays, that, you know, and where some might grumble that digital information or even paper information doesn't exist to what happened in the past, it's making the current information that we're creating as accessible for the future. Somebody will follow us. You know, I think it's something that's on our minds this week, I'm sure. Something will follow us, and therefore, you know, how do we make it as simple and as straightforward for them to do so? Jules, I'm going to come to you to see what your thoughts are on this retrofit of existing buildings, you know, and how we can use technology best, and what we can potentially do, please.
Thanks. I mean, I think we're all in riotous agreement that the lowest carbon impact material is whatever is there already, rather than putting something else in. And I think Simon and Marty talked really clearly about how actually it's really difficult to use technology to work out what's there if there isn't a decent track record. And it's not particularly helpful to say, well, what we should do is not start from where we are today, and we should start from a position where we've got, but let's at least acknowledge that for next time, let's make sure we've put ourselves in a position. And Marta, I think this is what you were saying as well. Let's make sure that we build, you know, we have decent BIM models, we've got a digital twin, and that we have the data flows and the sensor arrays such that we can actually understand what's going on in the building, we can understand how it works. But also I think it's really important that we put the processes in place so that when someone comes and changes something, it gets documented. Because I think generally the reason these sorts of things break down is because no one has put the processes in place to update when things get changed. So you know, we should acknowledge that it is really difficult still to use technology to really deeply understand exactly what is and isn't in a building. And Marta, I'm enthusiastic about you fixing that problem as everyone else is. But let's also help each other by meaning the next time we've solved it. I think the thing that I would say in terms of technology is, or the technology that we put into buildings, is to make sure that whatever we're procuring is, as everyone has already said, is flexible. It's really negatively impactful if you're putting technology, which we all know evolves much faster than concrete frame technology. You know, the lighting array technology will evolve much faster than that. It's really, really bad news if you put something in and then 3 years time have to rip it all out and replace it. So put stuff in that you've thought through for the future. You've as Wide School will tell everyone enthusiastically, make sure you think this through, make sure you've got redundancy in the system, make sure you've got resilience in the system, such that you can update it, you can improve it without having to put expensive, both financially and environmentally, new hardware in. And to me, that's key. There's, you know, it's very difficult to solve historical problems. Enthusiastic for us to achieve that, but let's try and at least make sure that we're not making the same mistakes again and again, I think.
Thanks, Jules. A very wise words. A collaborator that Buro Happold uses in the University of Bath said that, you know, how would things be different in the construction industry if the materials we were using were made of gold? We'd all work away to use a lot less of them as quickly as possible. May, I'm going to just ask you finally on that point about retrofitting of existing buildings and technologies before we come to the next question, please.
I think, as everyone's mentioned, one of the problems is the lack of information about buildings at present. And whilst you can go in, you can do laser point surveys, you can create a BIM model, it's always going to be incomplete. So your decisions on how you retrofit is based on some assumptions, some guesswork, some knowledge of different things. And part of that problem will be, what if you make those decisions and then find who the people designing that, the people installing it, are they going to promise you that in 5 years from now, it is going to be a sustainable building? Possibly not, because they may be using materials they haven't used before. They may say, well, I don't actually know all this about your building, so I can't promise you that. And then in 5 years, as was mentioned, you have to rip it all out and do it again. There's a number of buildings which you see reported which have been retrofitted and end up not being sustainable because how they're being used. And that's something to bear in mind. If you are retrofitting, are you assuming it's going to be used for an office? Is it possible to be as flexible as it needs to be? Because a lot of buildings aren't. There's been mentioned a couple of times about how we move forward. And one thing I would note about that is in terms of format of the information. So showing my age, if you have floppy disks, it's fine if find a computer that has a floppy disk drive to read this really important information, or mini disk. If you have an old version of something, you may not be able to open it. And if you're retrofitting, you're thinking, well, you're going to retrofit it in 10 years from now. Can you guarantee that you're going to be able to use that information? That's something that I think the industry really needs to think about, because otherwise we're going to sleepwalk into that problem.
May, I think you might be showing the age of a number of us who remember floppy disks and mini disks, and the fact that they might as well be in the bin nowadays because we have no way of getting the information out of them at all. A really, really sobering point for us all in terms of thinking about how what we even create today, let alone what we can find in the past, needs to be accessible. Can I move on to the next question? I'm going to start with you, May, if that's okay. Sorry, I've just realised I've just asked you the previous question, or the final one, but there we go. This is something that I know is dear to your heart from many of the conversations we have. What if technology is wrong? What are the risks of using technology in this way to really help us drive these retrofits, to think about whether we should demolish a building, whether we shouldn't? You know, we're using it, we're deploying it. But what if it is wrong? What are the risks and what's the recourse?
So I'll start with giving you some sobering figures. It's from an Autodesk report actually called Harnessing the Data Advantage in Construction from this year. And it said bad data may have caused 14% of all construction rework, equaling to $88.69 billion in avoidable rework worldwide. And bad data also costs 1.84 trillion due to poor decision making. So this is even more concentrated in this area because you are making lots of assumptions about how someone's going to use the building, how it needs to be sustainable, how your refit or your certain works on an existing building are going to last. If all that data that you go in, you survey the building, you're making certain assumptions. If that data is bad, you feed it into the technology, bad data in, bad data out. You then 5 years later find actually the building hasn't been sustainable. It would have been better to tear it down and start again. I think that needs to be catered for. Another point, and it ties to my point earlier about interoperability. If all your project team are using different types of software, different versions of software, which don't quite talk to each other properly, and there's gaps in the interpretation, and that impacts the design decisions that are made, the construction decisions. And so your end result isn't as productive and efficient as possible. Who's to blame for that? And things like that, you end up having a lot of people pointing fingers at who should bear the liability, and all the benefits from retaining a building disappear. Another issue which I have seen over the years is the issue of copyright. So if you have an existing building, you may have a slight complication of who owns the original design that you then need to amend or develop. Are you entitled to do that? If you get that copyright license and you then develop that design, but something goes wrong, who then bears that responsibility? And that can end up in a very long-running, expensive dispute, which isn't going to benefit anyone. I think one of the ongoing issues also is just pure computer or software errors. If someone puts information in slightly incorrect way, there's a software bug which impacts again how the build occurs and the efficiency of it. And again, the end result doesn't produce what was hoped for. And I think there's no way of completely eradicating that. But what I find with a lot of digital processes, what a lot of people are doing with, say, their contracts is saying, we want some stuff, I want this to be net zero carbon, full stop. It's like, what do you actually mean? And the end result you get is probably not what you imagine. Whereas people have to sit down and be quite prescriptive and have that discussion, write it down, because the person you're talking to now isn't going to be the person looking at the building in 5-10 years from now. And they won't know that you had this nice discussion about what the building was going to deliver. And they may have different expectations.
I think that was super, if sobering. I can see Simon making some notes. And I think there's some wise words from many of us on the call about the potential pitfalls, documenting, thinking about what the future looks like, thinking about what we're recording, thinking about, as you say, interoperability. There are real challenges there. Jules, can I come to you and let me know what you think about how we can manage the technologies wrong and the risks and the recourse?
Enthusiastically, this is the subject dear to my heart and dear to WiredScore's heart, I think, because it's really easy to get the technology wrong in buildings. It's frighteningly easy. And just before I sort of actually answer the question, I'd briefly like to pause on, so how do you not get the technology wrong? Because we should all be thinking soberly around the consequences of, but let's try and avoid it in the first place. And my view, our view, is that you need to start with the outcomes. And that was, May, what you were talking about towards the end, is start not from the technology, but from the outcomes, and be really clear during the design process, during the procurement process, what it is you're trying to achieve, and then build the technology on the back of that. And I think the mistake that we very often make is we start with the technology. And if you start with the technology, it's inevitably not going to do quite what you wanted it to do. Whereas if you start with the outcomes, you're in a much better place to be really clear with everyone involved, and particularly internally in a company, the people making the decisions, the developers making the decisions. If you're all talking about outcomes, you can identify where you disagree with each other, as opposed to you start with the technologies, and then 5 years later, when it's in the building, you realise you both thought you were talking at cross purposes. And so, what's the risks of it? The most likely risk is not great, but probably not the worst risk in the world, which is that you just wasted your money. I think the most likely thing to happen is that you find you've put technology in that, as I intimated, is not doing what you thought it needed to do. So you've wasted your money on technology that either is obsolete or it's ineffective, and so you need to put something else in. The other thing that you can do that I think I've seen quite a bit, that again leads to being completely wasted, is not have thought about that change management properly. You hear frequently tales of these wonderful smart buildings being created, and then the management team arrives, doesn't really understand how it works, so just turns off all of the automation because they don't really understand how it works, and they're frustrated that something's not doing what they think it ought to do in the moment, so they switch off all the automation, and again you've wasted the money on it. That I think is the most likely risk. I think the most impactful risk, though, is the cyber security risk, which can have enormous consequences. By putting technology in buildings, we're dramatically increasing the number of access points for a hacker, and you really need to think about that at every stage of the design process. The consequence of the building being hacked can be quite substantial. I mean, there are these. I've read this story several times for several different buildings, and I therefore put a huge health warning on it, because I suspect it's largely apocryphal, because I don't believe exactly the same thing possibly could have happened in multiple buildings. But the stories of people managing to hack in through a building through a connected device that you then leap through onto other devices in the building, and the version that always seems to appear always seems to be the thermometer in the fish tank. And I'm not quite sure what it is about fish tank thermometers that are so insecure, but apparently that seems to be. So I think it's largely apocryphal, but the point I think is well made, that if you don't think about the cybersecurity as you're putting all these connected devices, all these smart building devices in, it almost certainly will not be the one that was the highest value item that gets hacked that then leads on to something else. And just to think of examples of things that could happen, and I come from a landlord before this, and it was the kind of thing that would keep us awake at night. What happens if our flagship client, some bank, someone breaks into our network in the building and switches all the fire extinguishers on the trading floor and destroys all the computers across the entire trading floor? The sort of consequence of that feels quite sobering to me. So I feel I'm now rambling, so I'm going to stop. But I'll say the most likely issue is, I think, is the financial impact if you put the wrong technology in, and that gets resolved, I believe, with starting with outcomes. And then I think the highest impact that used to keep me awake at night on the landlord side was the cybersecurity risk. And that is then less about outcomes. That's more about being super clear about what the technological foundations you need to have in place in order to underpin all of the rest of the technology and all of the outcomes you're trying to deliver.
Again, a really quite sobering set of thoughts there from you, Jules. I think I'm getting more and more nervous. Whilst realizing there's great opportunities, we just need to go in as professional consultants with our eyes wide open. Marta, can I come to you? And then we'll come to Simon.
Yeah, sure. I'll pick up a theme that I think May and Jules both touched on, which relates to sustainability. You know, what's the biggest risk? And if we don't hit our goals, I mean, outside of life safety, let's put that aside, because I think that's always prioritized. I think you're right, Jules. You know, a big risk is loss of money, or big bunch of waste because you've made the wrong choice and you need to go back and redo. I think that is real. But I think the sustainability objectives, the outcomes around, we want it to be energy efficient, net zero, you know, whatever the sort of initial outcomes are targeted to be. I think that's a really unfortunate risk that we need to be thinking about. And I love your point about change management, you know, this idea that we could design this super smart, amazing building, and if you haven't anticipated the handover process, the whole thing could just fall in its face. So this is something I think about a lot around, you know, this transition from the design process to the operations phase and how critical that documentation is. So to May's point about, you know, being really clear about what did we do, what decisions did we make, and why, I think documenting all that is super important. I think there's huge opportunities with digital twin to be a record-keeping space for that information. You know, we can transition from a BIM design environment to a BIM operating environment and have a repository of all those decisions, the whys and the whats, the operating manuals, hopefully some training guides, and that should hopefully ease that transition so that those sustainability outcomes aren't nearly as compromised as maybe a clunkier version of the past. So let's hope that technology is really leading us in that positive direction.
A certainly more positive look on the concerns of deploying technology and the risks. Simon, finally to you on this one.
Yeah, it's quite a scary conversation, isn't it? I think with any new technology, like going back since humans have been inventing things, there's new disasters, as Jules was hinting at. We might be creating some things here that we don't know yet. But I think that the fundamental point is it depends on the scale of the problem, but actually technology should just be a tool for us. We need to understand what it's doing. We need to question it. And we need to understand the decision making behind it. It's us that holds the professional liability insurance, not technology. So we've got a responsibility, I think, to understand that. I'm sure there will be things that happen, but I think that issue of having to communicate what the design is supposed to do and how it's supposed to work to its end users is a really important one. And so just handing over an O&M manual doesn't do its full job. And I think technology could actually help in this. We're seeing a rise in building apps run by organizations and so on. these can all help us communicate, I think, to the building users how things are supposed to work. They haven't gone wrong. They're just not necessarily being used as they were meant to. And I think that issue of being able to communicate, hand over a manual to people, but shouldn't be a manual because that's too overbearing. So using technology to communicate this to people, that they're supposed to open windows when they get too hot, you know, at a very simple level. If it's too hot here, it's nice and cool over there, so go and move. I think some of those things will start to feed back in, and that's where technology could actually help us solve the problems technology might create.
Thanks, Simon. I think that is that real balance about the fact technology is useful, but we're all dealing with human interfaces, and actually helping us as people understand what we can do, should do, ought to do, might do under certain circumstances is going to be the real challenge. We need to deploy the technology to help us guide those decisions, but we actually need to act on it ourselves. I've got another question now, and I'm going to start this time with Jules. And again, this is hopefully in your sweet spot, Jules, in terms of the role you play. As we begin to pack buildings, both new and old, with technology to monitor performance, and considering how environmentally and financially expensive technology infrastructure can be, what steps can we take to encourage reuse or recycling of this type of technology? Should we include technology infrastructure recycling as part of a refurb or new build embodied carbon calculation?
Thanks. So yes, it seems very clear we should. If you're going to measure embodied carbon, you should be doing it properly, and that includes paying attention to what you're reusing, what you're recycling, whether that's in the steel frame or the lighting circuit. I would like to pause briefly though on the assertion that technology infrastructure is environmentally and financially expensive. It's obviously not without costs, but as we discussed at the top of the call, I think the environmental impact of this stuff is more than compensated by the improved efficiency during the life cycle of a building. We discussed at the top of the call that we should be putting technology in buildings if we want to achieve good outcomes with them, and that includes environmental outcomes. And then in terms of the financial cost of them, it's been a sort of a mission of my life, it almost feels, over the past decade to persuade people that the cost of this is not insurmountable, and actually it never ends up doing the most one could possibly do in terms of tech and tech infrastructure in a building. Never amounts to more than a very small number of percentage points on the capex cost of building a building in the first place. So, but that's not to say that there is no cost. So we absolutely should be encouraging recycling, encouraging reuse, and I think, as I said earlier, I think we all acknowledge that the lowest possible carbon impact material or technology is the one that's already in the building. So we should absolutely reuse it. Where we can't reuse it, we should recycle it. And I came across a week or two ago a really interesting company called Globechain, that's their business, is to create a recycling network for buildings being built that can't reuse things, because we do acknowledge that you can't always reuse things. I think the biggest thing we can do here overall, though, is to analyze properly what the carbon cost is and what the financial cost is of making these decisions, which goes back to my sort of quick answer of yes at the beginning. Of course, we absolutely should be taking this into account, and the better we can get at properly understanding the embodied carbon in a building and the carbon impact of taking something out and the carbon impact of putting something new in, the better the decision making we can adopt. And so, for example, one thing that I'm never terribly clear about when I'm talking with people about this kind of assessment is what you're assuming about the decarbonisation of the grid. So, for example, you've got a lighting circuit, you've got a lighting array in a building, and you need to make a decision whether to strip it out or not. There will be elements of that decision that are about financial costs. There'll be elements of that decision that will be about user experience and flexibility. But there's also, of course, a huge element of that that should be about what is the carbon impact of doing it. And I believe that you should be comfortable that by stripping it out, and the embodied carbon cost of stripping it out and putting something new in, that there is a carbon payback in terms of the greater efficiency will pay back at some point in time. But what are you assuming about the decarbonisation of the grid? Because that would be a very different decision if you believe we're not going to get carbon out of the grid for 10 years than if you believe it in 2 years. And being really, really explicit to that level of detail, I think, is what we need to do in order to properly encourage reuse and recycling, because I think there are all sorts of unknown or factors that are just deemed unmeasurable that we just don't take into account, and that will not help us make the right decisions in terms of reuse of materials.
Thank you so much. As you say, there are great opportunities, but again, there's real things we need to do in terms of thinking about how we can reuse things really effectively in order to push this forward. Simon, can I come to you for some thoughts?
Yeah, sure. I mean, it's difficult to comment probably on technology specifically. Jules is better qualified for that, but I think those principles go for everything inside a building. I think we need to, as an industry, develop more of an ecosystem which is tailored towards reusing and recycling things. And retaining things where possible, and that's going to need a lot of work and a lot of sophistication, I think, to get that in place. In terms of technology, you know, I think it is something that's measured. We had it measured when we were going through a carbon neutral assessment as a business in terms of our servers that were being bought, for example, and it's quite hard work at the moment to get those things recycled or repurposed in some kind of way. So that sophistication hopefully will improve over time. But as Jules was saying, we just need to start measuring these, and we need to understand it in a lot more detail. And it goes for us from everything related to the technology, which is less now because we're switching over to Wi-Fi quite a lot of the time, but the conduit and trunking and plasterboard and partitions and light fittings and AC units, you know, there's so much carbon that is in these buildings. What are we going to do with it? And, you know, the title of this webinar, is it ever okay for demolish? Well, it should never be okay just to chuck these things away. We always and should be questioning, how can we reuse these and extend their life at least in some way if they can't be retained?
Thanks, Simon. I'm going to come to May for some thoughts, please.
I think, as Jules and Simon have indicated, it's important to be very clear what is intended to be achieved and what technologies want to be implemented. And if you back engineer it later, after we've already implemented things, already designed certain things, it's going to be more expensive, less efficient. So parties have to say, okay, what do you, in the medium long term, what do you actually think this is going to achieve? How do you want to use the building? And then have a set of requirements, have an agreed position accordingly. I think the other point would be that technology is not the panacea. And sometimes people will say, well, I don't particularly understand all the technologies, but I want it all because I've read that it's going to make the building better, it's going to make it more sustainable. I just put it all in. And what that ends up, they get really disappointed because they don't get what they thought they should. And it's very expensive, so they don't get the return on investment. So it's more is not better. And it is, again, having the patience to sit there and say, maybe you just need that little bit of technology. You may just need sensors in your building, or you may need something else. And what will make it the most sustainable, efficient building, that means it is better not to demolish it. And that informed decision about technology, I think, needs to happen.
Thank you. That is really super, you know, in terms of thinking about, you know, how we minimize the impact of what we're doing and really go into these things consciously. Finally, I'm going to come to you, Marta, if that's okay, for final thoughts.
Sure, final thoughts. Thank you. You know, this is a tricky question. It's a bit of a chicken and egg in some ways, right? Because we're talking about needing to sort of put in technology to measure and monitor, and also think about the end of life of that technology when we don't even know what its life is going to look like. I think this is going to be a journey as well. I hate to come back to that, but as this technology is changing and as our use cases are shifting around our buildings existing, and if we need to renovate, I think there's a huge opportunity to think about, as Simon was saying, you know, how are we measuring the performance of it in the first place? How can we learn from those decisions that we made in the past? How are we keeping track of all that? You know, it's to scale out to the point about the grid, which was brought up. I love that. You know, it also reiterates the point I think I made at the beginning of this conversation around systems thinking. You know, we have to think about so many scales of these decisions, and you know, it can make your head hurt sometimes having a systems thinking mindset around all these sort of integrated effects and downstream, you know, outcomes of that one upstream decision. But I think the more data we have around these different realities that we're living with, that, you know, we've inherited today, and also thinking about how we keep track and measure it, the smarter we can be for future decision making.
Thank you. That is really, really good. I think we've only got a couple of minutes left. I'm not going to be able to pass to some of the questions in the chat, unfortunately, because I'm conscious of the fact that in these webinars, the key thing is to allow you to all go back to your daily work by about 1:30. A few, you know, thoughts from me. I mean, frankly, trying to scribble some notes, which is why my head is tipping down. I think we've really thought about two aspects of technology here, both the technology that enables us to make decisions around what to do with a building, whether we can reuse it, what we can find out about the building in its current state, whether we can use it, redeploy it into a slightly different way to create a sustainable product for the future. And also the use of technology to get the most out of a building, to prolong its life, to actually learn about, you know, the building performance, optimize that, reducing its lower operational carbon, for example, as part of that, making the occupants' lives so much better. It's a real journey in terms of thinking about the pitfalls that can come from some of those. May took us through some of the challenges in that space around, you know, do we have access to data? Will we be able to get access to data? Are we using it? Do we own that? Is it copyrighted? It was another point that came up. A real challenge in data sets and technology. Fundamentally, I think we all agree that we need to find ways to minimize our operational carbon impact and also the embodied carbon impacts. If we can reuse, we must look to do so. Yes, it can be a challenge. We need to make sure by doing that, as Simon and Jules were saying, that we don't make things more complex and embody more carbon, especially as we don't know what the longer term prognosis are for all these. And, you know, these are huge challenges for all of us working, thinking about, you know, how we develop a built environment that's really fit for the 21st century, how we look at our building stock, how we look at what we have and what we can use and what we can redeploy, maybe not always creating new buildings in the future. I would like to thank really sincerely our panelists here today, to Marta Bouchard, to Simon Bird, to Jules Barker, and indeed my colleague May Wilfield. Thank you for your really exciting conversations and your really provoking thoughts. Have been really super useful to us all. Thank you to our guests who've joined us on the call. I'm aware that a number of you have posted questions that we haven't been able to get to today. I'm really sorry about that. We will be in touch with you regarding some of the answers to those questions as we go forwards. You'll see here as we close the call, the graphic record of the conversation around leaving data trails, thinking about how we demand data and how we can use it for the future. I wish I'd had that in front of me as I was trying to wrap up. Big thanks to you all for joining us today, and I look forward to seeing you on a future webinar in the not too distant future. Enjoy the rest of your day, and thank you.